Welcome everybody to another MBW champion playing Sudoku. And today we are playing 1-2-1. I didn't even notice it sounds like it's like 1-to-1. Yeah, it looks like an easier puzzle-ish based on what I was seeing. So I don't know. Lately I've been doing a lot of more difficult puzzles, so I wanted to kind of do this one a little bit differently and actually do a puzzle that may be a little bit easier. So let's see. All right, so the rules are as follows. Actually, I'll start the thing so you can actually see what's going on. So the rules are as follows. Normal Sudoku rules apply. So basically, in a grid, numbers 1 through 9 are in here. They do not repeat in a grid, and also in a row and also in a column. 1 through 9 do not repeat. The digits within a cage must sum to the small clue at the upper left corner of the cage. So there's only one cage in this whole thing, and it says 121. So basically everything that is inside this cage equals 121. The inequality sign points to the smaller digit. So if you're looking at this digit is bigger than this one. And that's literally all the rules. So let's go ahead and get started. Hopefully this doesn't take us forever. Like, again, I tried to choose one that was going to be a little bit easier, and I was like, there's only like one rule on here. Oh god, I jinxed myself here. But yeah, so obviously we're going to start at the the cage. I'm going to highlight this just so that we can see in a good color. Yeah, there we go. Just so that we know when we're doing this, like, this is the cage. Unfortunately, it doesn't look like there's the whole section, except this one's like close, but like the whole section isn't in a cage, because I was gonna say the digits 1 through 9 equal 45. So if this was like in the cage, we can say, well, 45 minus 121 is the rest of them, but we're not sure on this one. So I think obviously we're gonna have to use math on this one. How many digits are there? Let me get a notepad up, because we're gonna have to use math. Math is gonna be a main portion of this one. So let me see. Okay, so I got a notepad. I'm gonna make some notes. I don't know how I'm gonna make this, but so 121 is the sum of blue cells. All right, so the sum of white. Let's see that one. So we know in every grid there's 45. It adds to 45. If there's 9 of them, and actually I'll just bring this out just so that you can see it. If there's 9 of them, 9 times 45 is 405. Okay, so that's the total. So 405 minus 121 is 284 white. The other thing I want to know is how many digits are here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. 36. Bring that back up. So there's 36 within the sum. And since we know it's 9 times 9, it's going to be 81. Yeah, 81 total cells. which means there's 65. No, wait, 65. 45 white cells. Does that add up? 5 plus 6, 1. Yep, that's good. All right. I don't know if that's going to help at all. I don't know. The other thing I want to try, now that we have those numbers, and I'll just put it on the other screen. I can't keep it on this screen, so I'll just have it for reference over here. I'll bring it on if I'm like talking about it. But the other thing I wanted to say is, since this is a pretty low number, because we have 284 is the sum of the white cells, and there's only 36 blue cells and 45 white cells, so they're not even, but they're pretty close to being even for the amount of space that the blue cells and the white cells have, because again it says 121 is the number compared to 284. So in other words, there's more high numbers in the white cells than there is in the blue. So I'm curious to see what the minimum value is for every single thing. So in other words, in the blue cells, what if I put the most minimum values possible? What number do we get? So I'll kind of put it like this way. So if this was a 1, 2, what's the minimum here? It'd be that. If it was like that, what's the minimum here? It would be like that. Same thing here. 1 would be the minimum here. Minimum would be this. And then the minimum would be that. Minimum would be 1, 2, 3. And then 4, 5, 6. Now that we have that, let's calculate exactly what the sum is with this. So basically, the first cell. Actually, we could go ahead and put that just so that we can label it. All right, the first cell is 3. First grid, I mean, like, so basically, like, what's the sum of this? 1 plus 2 is 3. That's kind of how I'm calculating it. The second grid, I was trying to make it easier for you guys to see, but I don't know. Hopefully you guys could see that. Do I need it? Can I, like, oh, I could zoom in. Sorry, guys. I didn't know I could zoom in like that. All right. Fine. I'll just leave it like this. Just trying to make it pretty. I'm just gonna do that for you guys. And 9. Okay. Okay. So 3 is the minimum there. That's 12, and so that's 15. Sorry, apparently I'm not gonna highlight it because it's being annoying. All right, so 6 plus 7 is 13, plus 8 is 21. 21 plus 15 is 36, which makes sense because then this would be our 9 right there, and that would make it 45, so that's perfect. Okay, so the fourth grid right here is 1, making this 10, and let me see, 11, so that's 18. 18 plus 15, or sorry, 18 plus 10 is 28. Oh, sorry. Grid 7 is 0. This one's 6. And then it's 15 plus 6, which is 21. Okay. Let's add that all together. So 3 plus 15 plus 36 plus 1 plus 10 plus 28 plus 6 plus 21 is what? 120. Oh. That's interesting. So it's like one different from here. Ooh, okay. So what's interesting about that is that means that it's one number off, right? Say for example, like there could be a 9 in here instead of an 8, and then it would be 121. Ooh, that's cool. Okay, so that's good to know. So the all the blue cells is 120. I did do that right. 21, 6, 28, 10, 1, 36, 15, and 3. Yeah, okay, cool. All right, so we have one different. All right, so does that mean, let's start with the ones. Can a 1 not be here? Well, to be 121, this would have to be a 2. But we already said that the 2 is right here. But if the 2 is right here, that means the 2 can be here. And then the 1 could be here. Oh, that may not work. Oh, that's interesting. Ooh, okay. Interesting. I'm just trying to think to myself, like, so, like, if this is 2, it can't be anything more than that, though. Like, this can't be 4, because then it would be way above. So this can be 2, but if that's a 2, then the 2 would go here, and the 1 would go here. And if the 2 is here, because again, it would be here and here, that means the 2 would go here. The 1 still has to be here, so 1 would have to go here. I think this would always be a 2, 6, 7. If this was a 2, that is. Interesting. What we do know about this, though, is that this, because it's such a low number, it has to be here, and it has to be here. And no matter which one it is, it has to be here. Let's just catty corner this one just so that we can kind of view that a little different. So that's going to kind of land like that, right? This would always have to be this one. Would always have to be this one. Same thing here. This would have to be this one. This would have to be that one. So our 3, in other words, would be here. Our 3 would be here. We don't know about the 3 here, though. What we do know, though, is that 3 is going to go somewhere here. What about... Oh, actually, never mind. That's going to go there. Meaning that's going to go there. It's kind of like you can kind of see like where it's flowing. It's actually so weird. So like this one's can't be there, it has to be here. This one, since it's hitting that, it's going to be there. So same kind of thing. Like if this was that, like where would it go here? It would have to go here. Right? Actually, let's not do that. It would go up here. Are we sure that it can't? No, it has to be. It has to be. This is so weird. I don't know if I'm doing... I feel like I'm doing something wrong. Yeah, because like since 3, 4, 5 is showing up here, like the 4, 5 that is, like that would also make this here. That's so weird. Okay. I guess, and then have that one here, have that one there. This is gonna do that, right? Yep. Okay. This is an interesting puzzle. Okay. So I just wanted to lay it out this way. I know it's a lot of colors, but like it's interesting. Like, so this is going to be the same of here and blah 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 and vice versa, right? I'm going to start dwindling down the numbers in just a second. But what we at least know is this one can be a 9. These ones can't, because if this was a 9, it would have to be here. That's the interesting part. So like this can never be 9, because then it would be there and it would make the sum a lot bigger. So this can be an 8 or it can be a 9. And what's going to end up happening, as I kind of showed, is this oddity here, because of the way that this was structured. Since I know that this number is right here, and I knew that it was going to be here, I know the number that's going to be there. Because again, like, in other words, if I kind of compare all these, it's like this is a 3, 4, 5. Well, that means there's no 1, 2 here then. But then this is also 1, 2, 3, so that means there's no 4 in it, so there's no 4. So all the blue ones are a 3, and I already knew that, because that's why I labeled 3 here. But I wanted to kind of prove it as I was going along, and it's legit working, and it's so weird. It's literally so weird. But anyways, so all these ones are going to be 4. All these ones are going to be 5. Yellow ones are going to be 6. Brown ones are going to be 7. And And then, I already did them. Okay, never mind. Oops. All right, and 6, 7, see that. So, just like I was saying, this is going to be an 8 or a 9. And it's all dependent on this. Like, it's literally saying, if this is 1, that means this is going to be 9. But if it's 2, and I only know that because of this. It's the green one. I know I was showing it right here. It's easier to see right here. If this is 2, which is going to have this, that means this one. Like, these are the ones that are depending on each other. If this is 2, that means this is 8. But if it's 1, that means this is 9. And that's so weird. Okay, cool. All right. Since we know this, I'm going to get rid of all the colors. I guess except, I guess I should keep these ones just so that we know which values they're going to be. But I'm just going to get rid of the colors just so it's not confusing anybody. So, here we go. So, let's do Sudoku and see if we can find anything. So, this is going to be a 6 or 8, 9. 4s, like, there's going to be a 4 here. 5's already done. 6 is already done. 7, actually 7 has a number here. That's interesting. So this is going to be an 8, 9 right there. So this is an 8, 9. That's an 8, 9. Interesting. This is going to be a... I know it's going to exit out with the 7, but I'm just going to label them here. It's going to be a 6, 7, 7, 8, 9. All right, so there's no 7 here. This 8, 9 is seeing this, and whatever this is going to be it could be catty corner to there. This 89 is seeing this, so the 6 is right there. Oh, that's going to actually do this. Nice. Okay. What about 5s? So 5 right there, so there's going to be 5 up here. 5, it could go anywhere here. 5, it can go anywhere here. I don't know why I want to label the 5s right here. Actually, what I do know, though, is that the 7 is going to be up here. Sorry. The 7 is going to be up here, which makes this 7 here. And we actually know that this is going to be a 6, 7, 9. Interesting. What that does mean, though, is that this can never be 7, because this has to be bigger of whatever this one is. So this one's never 7. If this is 8, then that's 7. But if it's 9, it could be 7 or 8. But what that does do is it does see this whole column. That means there can't be an 8 or a 9 here. So what are the only things that it can be? I think I just broke my own logic there. I just said that I can't have this be here. Did I do something wrong? I did something wrong. Ah, phooey. This 89 is seeing this anyways. You know what? I made an assumption that's not correct. I know exactly what I did. Oh, it was such a long time ago, though. It's okay. It's okay. I'm going to just do it anyways. I'm going to backtrack a little bit. Okay. I think that's far enough. What I was saying here, this has to be locked in because of the minimum. Like again, this has to be a 1 or a 2 because I can only let it go up once. This is locked in here, so it has to be there. Because let's just say if I say that this is a 6, like the only way to get like here, right? Like if this is low, like if this is an 8 and this is a 6, that means a 6 can't go here. And because of the other logic that I was doing, I can't put a 6 there because then it would go above 121. So in other words, the only one that cannot be set is either this one, or this one. I assumed that it was only going to be this one, but now that I'm looking back, like obviously since I saw that didn't work, now that I'm looking at it, I can have an 8 right here. Right? I can have a 7 right here. Though, if I do have a 7 right there, it would see... It would see this one. Did I do something wrong? I feel like I did something wrong. Because if I have 4, 5, no, that works. I feel like this still is the only one that can be an 8, 9. Did I just like accidentally like put in a wrong thing somewhere? Like, can I switch to 7? Like, if I switch to 7s, is that possible? Like, I switch to 7s and then the 6s. Does that still work? I'm gonna go backwards real quick. Maybe I assumed that those numbers were gonna be actually there. You know what? Since these don't complete, like I think think these have to be 3. For that reason that I gave here. Like, if this was a 3, 4, or 5. Or what I'm saying is like a 3 has to be in here, right? The only possible solution for it. Or maybe not. Why did I start doing those colors again? Because I know this is right. I'm just going to break it down again. I have to go backwards, apparently. Okay. So. I know that this is 3, 4, 5. I don't know in what order it's a 3, 4, 5. It was this one. That was the key of it. Since I know that there has to be... There has to be a 1, 2. Yeah, that's what it was. Okay. Started at the green. The green has to be there, which makes it there. This makes it there. That makes it there. So the greens are good. The orange is there. But what it doesn't do, that's what it is. I messed up. Okay, I see what I did. I assumed that it was going to be always here, but it could be here too. Okay, let's get rid of all these colors. Well, my bad, guys. I'm just going to get rid of the colors all everywhere here. Okay, so let's try this again. So the green has to be there. Green sees that. There we go. Green. And what that also means is that this can't be a 3. This one, we know has to go here because of that green. Or that one. But what we don't know is we don't know where it goes here. Oh wait, we do. So I was doing it right. Ah, dang it. Okay. That's a 3. Okay, apparently I was doing it correctly. Where did I mess up then? Maybe it's here. Okay, so that's a 3. That's a 3. That's the 4. That has to be the... I feel like it's doing the same thing. Oh my god, what did I do wrong then? Again, if this is 7... I can't worry about it right now. All I know is the 5, 4 hits that, so this is... But can it be a 7? Let me see. If it's a 7... Yeah, if I approach it from the other end. Like, let's just say that this is an 8. We know that that's there. We know that's there. We know that that's there. This is always a 7. What? Did I do something wrong with the math in the very beginning? The inequality sign points to the smaller digit. I was trying to make this an... But it was 1 off. It was only 1 off. How could that be... See, here I am thinking that this was going to be an easy puzzle. Boy, was I wrong. Could be any of them. Actually, can this be any of them? Like if the 6 is right here. No, because then it goes over the limit because we have 120. It's only 1 down. This has to... Why... This is not working in my head for some reason. Because, like, let's just say this is like a 5, 6, 7. It not being... That's already more than 1. Never... Ah, dang it. Can this ever be 3? No. I feel like... Oh, dang it, sorry. I feel like just something's just wrong. I'm like half tempted and just like starting over. Let me maybe bring out my... It's so stupid. Like, let me see. 1 plus 2 plus 3 plus 4. This is so stupid. Minimum on the first grid is 3. That's 15. Sorry. 6 plus 7 plus 8 is 21. Plus 15 is 36. So that's right. Minimum, that one is 1. That's 10. 5 plus 6 plus 7 is 18. So plus 10 is 28. 6. Again, plus 15 plus 6, 21. So that checks out. Let me just do that adding again. 3 plus 15 plus 36 plus 1 plus 10 plus 28 plus 6 plus 21. 120. I know it's stupid, but I'm just gonna back out of that really quick. So, if this was let me just get rid of everything. No, I can't do that. I can't do that. There's no way that this can be an 8, because then this would be a 9. This is 80. This is 89. This is 89. Maybe something funky is here. Funky is happening here. Can this be? If this is an 8, what if it still works? Oh, this is killing me. I don't see. I don't see the reason. How long have I been going? Am I doing the math wrong? Because again, if this is 3, I'm assuming that this is going to be like let's just pretend it's like a 3-1. Can I do this where this is still a 1-2? To be the minimum. What are you doing, cat? If this is a 3-1, because that would make this 4. That I had something. I don't. That would make, so that would make it 4. I could still have 2 here. No, but then I wouldn't have 3, 4, 5. Right? Right? This can never be a 3. Because again, like then where would the 3 go in here? And if I put another 3 in there, it's going to go 1 above it. I still feel like that means that these have to be the 3. I'm gonna do this again really quick. That was the 4. That was the 4. That was the 5. Did it? Right. That could still be the 5. Four, seeing that, yeah. So 5, 4, 5, 5. Let me stop there. I need to really figure out I need to figure out this. Actually, let me get rid of the... We know at least that this has to be the same one. I'm still trying to think if this, like, if this is gonna work. Like, can this still be 8? That was where my original question was. If this is 8, because the 6, damn it. If this is 8, this still has to be 6. Because this would have to be 6, and then that would have to be 6. This is 7. Seven, 7, 7, and this would have to be the 6, 6. And 8. Actually, that does work. What the hell? Wait, hold on. I know the minimum here has to be a 6 or a 7, right? Which means, like, if this is a 6, there could possibly be an 8 here. This has to have a 6. Can it ever be 9? Oh my god, my brain is hurting. How long have I been doing this? I can't. I can't have a 6. Oh my god. Maybe. So either this is going to be a 6, 7 or a 6, 8. What I do know is that there's a 6. I don't know if that's helping. It makes me feel better though. But it means that this can have a 7 too, which would make this a lot better, because I can finally put like a higher number there because of that. I was just gonna say, can this be a 6? Oh. Dang it! If there's a 6 here, and it's a 7. That means that this could be an 8, possibly. So possibly this can be a 6. Like if this is a 8. No, there can't be an 8 because then it would go 2 above. So this can never be an 8. Because these are the minimum values. If these are the minimum values, 6 is 1 below 121. So if I put an 8 in there, it's not going to work. So this can never be an 8. This is a 6 or a 7. Whatever this is going to be, it's going to be here. Not necessarily. Not necessarily. I just know that it wouldn't be there. That at least means that there's an 8 here, 8 here, and an 8 there. We know that there's a 9 here for sure. So we just don't know if there's a 6 or a 7. There can never be a 6 here because this has to be big. So this 7, 8, 9 triple. This can't be a 7 because then this would be a 6. And this has to be a 6 or a 7. So this can't be 7 because this, well, now it can be a 6. But in other words, this can't be a 7 because the only possible thing is a 6, but this is a 6, 7. So this is an 8, 9. So this is a 7 because the 8, 9 is seeing this. Which means if this is not the lowest one, that means 9 cannot go here. Let me do my math again. Or not, where's the notepad? Notepad. So these are checking out. These are checking out. This is where I'm saying that the plus 1 is. And as long as I keep that one a 6, because it would be 6. I'll erase it if it's not going, but this would be the 6. This would be an 8. The 8 would go here, and the 7 would go there. And that does work. Like outside of the box, I'm not looking at the outside of the boxes, but That does check out.
I don't know, but I found these results on search.
That does work. Yeah, this is adding up. This is adding up to 121. So that's the other, like what we were saying earlier. We proved that it didn't work with it having a 9 in here, right? I didn't think that it could go the other way, where basically like these numbers switch, because right now it's going 3, 4, 5, 6. Like it looks like it's going in order, but this right here switched around. That's interesting. I didn't think it was going to do that. It seemed very consistent, but this, the other rule, the only other rule, got determined because we figured out that this could be a 7. Like if this is the one right here, that's what checks that out. So that's right. My Jesus, I think we got it. I'm kind of scared. Like, I don't know what just happened. Oh my god, my brain hurts. I thought this was going to be an easy one, and this is way more difficult than I thought. Anyways, what we have to do though is we have to make sure that that everything's the minimum, because we made this an 8. Everything has to be a minimum. So the minimum has to be 1. This has to be 2. And I'm just going to get rid of all the bookmarks and then just do Sudoku. But I think that's it. Okay. Yeah. Oop. I just got rid of the things, and now I'm putting things there. Okay. Yeah. Anyways, it's because of this part. Like, it's so interesting, right? We know that this had to be a 7, 8, 9, but obviously this is seeing that, so this is going to be the 8. This is going to be bigger than those digits right there, but we used all of them in this here, so that's a 7. That's our 9. Get rid of that. All right, 9 is seen right there, so this is our 9. 9 is seen right there. We could basically fill this in. So because the 1, 2, 3 is here, 1, 2, 3 is here, this is the 1, 2, 3. This is the 4, 5, 6. This is the 4, 5, 6. This is the 5, 6, 8. I'm just kind of labeling them all there just so that we can just start doing our Sudokus. Or Sujokes. My God. You're a joke. Anyways, I'm just putting them all in, and then we're gonna clean it all up. So 5, 6, 8. Yep. Okay. Cool. All right. So the 1 and 2 in those sum cells are gonna be seeing that, and then we're gonna kind of just rock and roll around the circle. So now that we have that, that's gonna equal that. Boom. Boom. That means this is our 6 because the 8 sees that right there. Make that the 5, make that the 4. I guess we could just fill these in. Oh, that's 3 in the corner. That's 3 in the spotlight. Losing my religion. Oh my God. I don't know if I solved that correctly, or I mean, obviously I solved it correctly because it says, "Hey, congratulations, you did it." But I don't know if I did it in the right way, like, because I determined that was going to be an 8, but my logic was very like elongated, and I don't know if that was the way that it was intended to like find that section, but it worked. So since it worked, I'm like, oh, that actually makes sense. Like everything's falling in line, because like the difficult part of it was like I was so occupied here of making this a 7, like because everything's kind of going in order, like 1, 2, 3, 4, 5, 6, like everything's in order, right? And so like I was so hyper focused on it that I assumed that this was a 7, but it wasn't, because of like the ending. Like it could, one of the ending numbers can be one number off, meaning it doesn't necessarily, like it makes the next number not really needing to be in that order. So like because I was so hyper focused on this one being the 8, I was like, oh, this is gonna be or 9, whatever. Like I was saying like, well, this is a 7 and that one's gonna be the 9, but like not necessarily. And that's the interesting part about this puzzle. Like I didn't think of that concept, so I'm still trying to wrap my head around it, and it's a good head around. Like I'm actually thankful that I did this puzzle, because like it makes me think of like outside the box. I don't know. I'm trying to explain what's in my brain and it's not coming out right. But either way, it was solved. Hopefully you guys did the puzzle with me. I thought it was gonna be an easier one because there was only one rule set, but maybe it was. Maybe I'm just a slow one on this one. Anyways, thank you guys so much for watching. Again, please subscribe, do all that stuff, ring the bell. I have a whole bunch of different video content. This one in particular, the puzzles, do this one every other Sunday. So check out another puzzle. Maybe I'll do an easy one. Maybe I'll do a harder one. Take 5 hours to do. I don't know. I'm crazy. Anyways, I'll talk to you guys later. Have a good one.